Okay. Yeah. Visible? Good. Guys, in the last session, we discussed about daemon thread. What is the daemon thread? Huh. The thread which runs in the background is called as daemon thread. How to make a thread as a daemon? Set a daemon to true. By default, every thread is a normal thread that we create. If you want to make the thread as a daemon, then we need to call set a daemon. What is the example for daemon thread in the Java? Garbage collector. So garbage collector is responsible to deallocate the memory. JVM is going to allocate the memory. Garbage collector is going to deallocate the memory. So garbage collector will run in the background. We are not starting the garbage collector. JVM will take care of that garbage collection process. After that, we discussed about synchronization. What is the synchronization? What is the synchronization? Synchronization means thread safety. When we can call our program is thread safe, if only one thread is accessing our method, then that is called as a thread safe method. If multiple threads are accessing at a time, that means it is not thread safe. So program should be thread safe or not thread safe, that it depends upon the requirement. All right. So synchronization we can implement at two places. To implement synchronization, we are using a keyword called synchronizer keyword. Synchronizer keyword we can use at the method level and we can use at the block level. Okay, when to go for synchronization at the method level, when to go for synchronization at the block level. If you want complete method should be executed by only one thread at a time, then we will go for synchronized method. In this method, complete logic is not important for me. Only some lines of code is important. Then we will go for synchronized block. Perfect. Good. Then after we discussed about this synchronized method, thread T1, thread T2. When I start these two threads, they are going to call the run method. Run method calling print numbers. That method is a synchronized method. It will first thread should complete the execution, then only second thread will start the execution. Because my method is thread safe, only one thread can access my method at a time. If I remove synchronized keyword, two threads will execute the method parallelly. Two threads will execute the method parallelly. If I keep synchronized, then only first thread will execute. After first thread execution is completely completed, then only second thread will execute that method. Practically, we are able to see that. Good. Now, let's go to our program. Let me take one Java class, new class demo. Guys, as of now, we created thread like this. Public class demo extends thread. Public class demo extends thread. Inside this, we are overriding run method. We are overriding run method. Can you guys tell me what is a run method? Can you guys tell me what is the run method? This run method is used to write the logic which should be executed by the thread. We are going for multi-threading. Why we are going for multi-threading? To execute our programs parallelly. So thread should execute my logic. Which logic you want to execute by the thread? That logic we are going to keep inside run method. System.out.println. This is thread logic. Something. I want to print this statement by thread. Then let's go for main method. Let's go for main method. Inside this main method, what we are doing? Demo D is equal to new demo. I'm creating demo class object. Demo D is equal to new demo. I'm creating demo class object. Then here I want to make this class as a thread class object. How to make this object as a thread class object? by using thread T is equal to new thread of D. Now demo class object became thread object. Now I am going to call T dot start method. I'm going to call T dot start method. Let's run this program. When I run this program, what is happening? Yes, I'm calling start method. When I call the start method, what is happening internally? Start method internally calling run method. My start method internally calling run method. This is one way of creating thread. This is one way of creating a thread. Now, there is another approach also to create the thread, that is called anonymous thread implementation. That is called anonymous thread implementation. Let me go to another class, new class as my thread. I'm taking a class with a name called my thread. Inside this class, I'm creating main method. Earlier in the demo class, I'm extending the properties from thread. I'm creating thread class object. Thread class object, demo class object I created. Demo class object I am passing to thread class object. Then I am calling T dot start method. I'm calling T dot start method. Here, I will not extend from thread class. Directly, I'm going to create object like this. Thread T is equal to new thread. Thread T is equal to new thread. As of now, I'm keeping semicolon here. When I keep semicolon here, what is happening? End of the statement. But now I will not end that statement. I will write like this. I will write like this. This is called as anonymous implementation. Inside this, I'm going to override run method. I'm going to override run method. System.out.println. This is run method. This is run method logic. T dot start. T dot start. It is the simplest way. This is the simplest way to create a thread. Earlier, what I have done, I have a class. My class is extending the properties from thread, and we are writing run method. Inside the run method, we are writing logic. Then I am creating object for demo. So demo class object, I am passing to thread class object. Then I am calling T dot start method. Then here I am not extending from thread. It is a normal class. My thread is a normal Java class. Inside that I have a main method. Inside the main method, what I am doing? Thread T is equal to new thread. I'm writing body for the object. I'm writing body for the object. Generally, methods will have a body. Now I am writing body for the object. So writing the body for the object, this is called anonymous implementation. What is this? Anonymous implementation. I'm creating body for the thread class. Inside the body, I am writing run method. With this, my thread is created. With this, my thread is created. Once this thread is created, I want to start the thread. I want to start the thread. T dot start. When I call T dot start, what will happen? What is it? What is the T? T is a thread. Inside the thread, do we have run method? Yes, that run method will be called. Right click, run as Java application. Is it executing now? Yes or no? Yes, it is executing. This is another way to create the thread. Now, I want to create one more thread, guys. I want to create one more thread. Can I go for runnable interface to create the thread? How many ways we can create the thread? 3 ways we can create the thread. What are the 3 ways? Extending thread class, implementing runnable, implementing callable. Now, let me go like this. Runnable R is equal to new runnable. Runnable is a class or runnable is a interface? Runnable is a interface. Can we create object for the interface? No. We need to create the object for implementation class. We need to create the object for implementation class. All right. Now here, instead of creating the object, I will create anonymous implementation for the interface. Are you guys getting my point? Anonymous implementation for the interface. Here also, I'm going to override run method. I can say system.out.println. This is run method. This is run method logic. This is run method logic 1. This is run method logic 2. I can say run method logic 1, run method logic 2. R is available. R is a variable holding which class object? Anonymous implementation object. Are you guys getting my point? Here, T1 is having anonymous implementation. R is also having anonymous implementation. This is shortest way to create the thread. This is the shortest way to create the thread. You can create the thread like this, or you can create the thread like this. You can create the thread like this. Runnable R is equal to new runnable. Runnable is an interface. I cannot create the object. I am providing anonymous implementation. For the runnable, I am providing anonymous implementation. Now, here R is available. Do we have start method in the runnable? In the runnable interface, which method is available? Only run is available. Why? Because it is a functional interface. Runnable is a functional interface. What is the meaning of functional interface? Only one method is available. Now, runnable interface, I can pass to thread T2 is equal to new thread. Okay, guys. Runnable interface, thread T2 is equal to new thread. Then I will call T2 dot start. T2 dot start. What is this? Creating a thread by using anonymous implementation. That anonymous implementation I am providing for runnable. That runnable object I am passing to thread object. Then I am calling start method. Execute this program. Yes, first run method is executed. Second run method is also executed. Similarly, can we create anonymous implementation for callable also? Yes or no? Can you tell me the logic for that now? Callable C is equal to new callable like this. Callable C is equal to new callable. Inside this, what method we need to override? Call method we need to override. Here it started, here it ended. Inside this, we can write the logic. System.out.println call method logic. Call method logic. Now, can I directly call C dot start or C dot run? Do we have any method in the callable? No. In the runnable, we have run method. In the callable, we have call method. Now, how to execute this callable now? Directly, can I create the thread object and can I call the start? No. What is the option we need to follow? We need to go for executor service. Executors dot new fixed thread pool of one thread I am creating. So I am getting executor service. Once I got executor service, can I call submit of callable? Yes or no? Yes. Now let's run this program. First approach, run method executed. Second approach, run method executed. Third approach, call method is executed. So here you can create a thread by extending thread class or by implementing runnable interface, by implementing callable interface. Here, am I implementing runnable interface directly from the class? No. Am I extending from thread class directly? No. Here, I am creating thread anonymous implementation. So thread T1 is equal to new thread body. Thread object is having a body. T is available. T dot start. When I call T dot start, internally it will call run method. Internally it will call run method. Now here runnable R is equal to new runnable. Runnable R is equal to new runnable. Here we are creating anonymous implementation for runnable. Runnable R is equal to new runnable. We are providing anonymous implementation for runnable. Next one, thread to T2 is equal to new thread. Runnable does not have a start method. Runnable, callable are functional interfaces. Runnable is having run method, callable is having call method. Runnable R is equal to new runnable overriding run method. Callable C is equal to new callable overriding call method. Thread object I created. Runnable object I am passing as a parameter T2.start. It will execute run method. Callable C is equal to new callable. Inside the callable, we are overriding call. Am I creating the object for the callable? Am I creating anonymous implementation for the callable? Anonymous, that means without taking a separate class, I am implementing the interface. In the Java, this is possible. You can take a class and you can implement the interface. Without taking a class also, you can implement an interface. This is called anonymous implementation. Okay, once I have callable with the anonymous implementation, to execute this callable, I am taking executor service. Can you tell me what is the executor service? Can you tell me what is executor service? It is used to execute a pool of threads. What is the advantage of going for executor service? Reuse the threads to execute multiple tasks. If you create a thread pool, you can reuse the threads to execute set of tasks. You can reuse multiple threads to execute set of tasks. Are you clear? Good. This is another approach to create threads in the Java. Okay, creating threads with anonymous implementation. Creating threads, working with the threads using anonymous implementation. Working with the threads using anonymous implementation. All right. Sorry. This one only, anonymous we will do. We don't create separate class to create the threads, right? Whenever I want to execute some logic by the thread, we will go for this approach. In every Java class. Huh? Less number of lines of code, right? You don't need to implement any interface from the class. You no need to extend the properties from any class. Directly we are creating a thread and we are executing the thread. Right? This is easiest approach and very less number of lines of code we are going to write. In the industry, mostly to execute logic by the thread, we will prefer this approach. No. It is anonymous implementation. If I end here, that is object creation. Sorry. Yeah, that is what, man, anonymous implementation. Hi, this Java ka syntax hai. If I create like this, if I remove this, if I end it, then it is illegal. Why? Because it is a interface. Without having that interface, without creating the object, for this interface, I am providing anonymous implementation. Anonymous implementation, nothing but it is going to create one Java class internally. It is like creating a Java class, implementing a callable. Instead of creating a separate class and implementing an interface, Java provided this easiest approach to implement the interfaces. Got it? So generally, if I want to create a thread, then what we need to do? I need to implement callable. I need to implement callable. Implements. I need to go for implements callable. Right. Callable is available in the concurrent package. Callable. Then what should I do? Override the call method. Override the call method. Instead of doing all these things, whatever the logic we are writing here, this logic is equal to this logic. It is something like a anonymous inner class. It is something like an anonymous inner class. Whatever you are doing by taking a class, implementing an interface, overriding the method. Here we are writing this piece directly. Understand? I'm taking a class, I'm implementing a interface. Instead of writing a separate class to implement an interface, that interface I'm implementing anonymously. That means here it is something like an inner class without any name. It is something like an inner class without any name. In the Java, this is possible. We can implement interfaces without using a class name. That is called anonymous implementation. This approach you can follow for every interface in the Java. Not only for runnable, not only for callable. For any interface, you can follow this approach. Later, in the Java 1.8, this concept also simplified. How they simplified this concept, you know. Callable C1 is equal to they have provided lambda expressions. Directly you can write like this also. Directly you can write like this also. That is lambda expression in the Java. You can directly write the statements without writing any implementations also. That we will discuss in Java 1.8 futures. First, we are going to create a class which will implement the interface. To reduce number of lines of code, Java introduced a concept called anonymous implementation. To avoid this anonymous implementation also, Java came up with a concept called lambda expression that will be covered as part of 1.8. That will be covered as part of 1.8 futures. Good. So this is another approach to work with. This is another approach to work with threads using anonymous implementation. Working with the threads using anonymous implementations. Perfect. Yeah, you can do like this. Now you can write an example. No. This is not a method, man. This is object. It is anonymous implementation. This is not, I'm not writing method inside the method. Am I writing method inside the method? This is one method. I'm not writing that. This is not a method. Na? It is anonymous implementation. Method inside the method is not possible, but interfaces you can implement anonymously. Inner class, yeah, we can say it is anonymous inner class. Okay, and guys, this is Sunday. We have a long session. Whatever chota mota topics are there, we need to complete all those topics by Sunday. Sunday morning or evening. When is your comfortable? Morning only. Pura din kali aap. So some small topics which are related to garbage collection. What is garbage collection? What is reflection API? What is generics and inner classes? Some small topics are available. These are small topics. Tomorrow and the day after tomorrow we will complete. Okay, so tomorrow we will work on garbage collection part. Tomorrow we'll start the class. Yesterday I canceled the class, right? Tomorrow I will compensate that. Tomorrow I will take the class from 5 to 8. Evening 5 p.m. to 8 p.m. I will take the class tomorrow. Sunday also I will take the session. These topics are not that much difficult. They are easy. So we can complete them in one day. So if we complete all these topics by this Saturday and Sunday, then from Monday we will start another big bull collections, right? That is very important. Very important topics. Got it? Sunday online le lenge. Offline. I need to check morning one class is there. I need to check their timing. If they don't have class on Sunday morning, then I can come to offline, no problem. क्या फर्क पड़ता भाई ऑफलाइन ऑनलाइन? ह्यूज डिफरेंस हाँ. Okay, perfect. Now let's understand a small pending topics in multi-threading only. Deadlock. Deadlock. एक मिनट भाई. हाँ. Deadlock. What is a deadlock? What is a deadlock? हाँ. Deadlock, nothing but ambiguity. Deadlock means ambiguity. Deadlock means ambiguity. Deadlock means ambiguity problem among the threads. Deadlock means ambiguity problem among the threads. If two threads are waiting for each other to release the resources, that is called deadlock. I have given one. This is, look at this guys. Look at this. Look at this diagram. Look at the diagram. Deadlock means ambiguity. Deadlock means ambiguity. There are two threads, thread 1 and thread 2. Thread 1 holding resource 1. Thread 1 is holding resource 1. Thread 2 holding resource 2. Straight arrow represents that thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 waiting for resource 2. Thread 2 waiting for resource 1, but both are not releasing the resources. Thread 1 is keeping resource 1 and waiting for resource 2. Thread 2 is holding resource 2, waiting for resource 1. Thread 1 will not release the resource 1. Thread 2 will not release the resource 2. These two threads forever in the waiting state. These two threads forever in the waiting state. That is called deadlock. That is called deadlock. If two threads are waiting for each other to release the resources, if two threads waits for each other to release the resources, that situation is called as deadlock. If two threads are waiting for each other to release the resources, is called as deadlock. Once deadlock occurs, we cannot resolve that. If your program enters into deadlock, you cannot do anything. Whenever you are writing the program, you need to make sure deadlock should not occur. Once deadlock occurs in the program, then you cannot do anything. Okay. Once we get into deadlock situation, then we cannot do anything. We cannot do anything. We need to make sure our code will not give deadlock. Once you get the deadlock, then you cannot do anything. Deadlock means ambiguity problem among the threads. If two threads are waiting for each other to release the resources, is called as deadlock. Once we get into deadlock situation, then we cannot do anything. What is the example? Example, thread 1 holding resource 1 and waiting for resource 2. Waiting for resource 2. Here thread 2 thread 2 holding resource 2 and waiting for resource 1. Waiting for resource 1. Here thread 1 will not release, thread 1 will not release resource 1, hence thread 2 will be in waiting state forever. Thread 1 will not release resource 1, hence thread 2 will be in waiting state forever for resource 1. Got it? Here, thread 1 is holding resource 1 and waiting for resource 2. Thread 2 holding resource 2 and waiting for resource 1. Thread 1 will not release resource 1, hence thread 2 will be in waiting state forever for resource 1. Now here, thread 2 will not release resource 2. Thread 1 will not release resource 2. Look at the diagram. Thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 is already having resource 1. Thread 2 waiting for the resource. Thread 2 holding resource 2. Thread 1 waiting for resource 2. Thread 1 will not give resource 1. Thread 2 will not give resource 2. Both will wait for each other. Both will be in the waiting state for each other. That situation is called deadlock. Once deadlock occurs, we cannot do anything. Whenever we are writing a program, we need to make sure that deadlock will not occur. Once the deadlock occurs, हम कुछ नहीं कर सकते. Are you getting my point? Right. So thread 1 will not release resource 1. Hence, thread 2 will be in waiting state forever for resource 1. Thread 2 will not release resource 2. Hence, thread 1 will be in waiting state forever for resource 2. Good. Thread 1 will not release resource 1. Hence, thread 2 will be in waiting state for resource 1. Thread 2 will not release resource 2. Hence, thread 1 will be in waiting state forever for resource 2. Thread 1 is waiting for resource 2. Thread 2 is waiting for resource 1. Both are not releasing the resources. Our program will go to deadlock. Our program will never terminate. Our program will never terminate. That is called deadlock. Theoretically, it is very easy. Thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 waiting for resource 2. Thread 2 waiting for resource 1. Both threads will not release the resources. Then it is called as deadlock. In the interview, they will ask a question. Can you write a program which will give the deadlock? To check your skill, they will ask. Once we get the deadlock, we cannot do anything. Nobody can do anything. Once the deadlock occurs, your program will hang. Your program will never terminate. But to check your skill set in the interview, they may ask to write a program which will give the deadlock. Can you write a program and can you show me how deadlock look like? Can we write a program? Can we see that? With the threads. Can you guys try that? Look at the diagram and can you try? Deadlock. At least try. At least try the program which will give deadlock. Write a Java program. If you run the Java program, it should give the deadlock. If you run the Java program, it should give the deadlock. Write a Java program which will give deadlock. Huh? Write a Java program which will give deadlock. Try.
Function also I started both. They will continuously call each other and wait for each other.
No. Synchronized blocks you need to write. Okay guys, let us see here.
रन मेथड में जो कॉल करेंगे दो मेथड बना लेंगे m2 m1 से m1 को कॉल करेंगे
नहीं वो स्टैक ओवरफ्लो हो जाएगा ना. Okay guys, so see here. How to write a Java program which will give deadlock. How to write a Java program which will give deadlock. New class. Let me write the class with a name called deadlock. Okay. Let me take main method. Let me take main method. Let me write two resources. String s1 is equal to something like hi. Then string s2 is equal to hello. I have taken two string variables. One is s1, another one is s2. s1 is equal to hi, s2 is equal to hello. Hi and hello is available. Then next one, I want to create two threads. First thread will hold s1, second thread will hold s2. Two threads I need to create. If I want to create two threads, do I need to create two classes separately? I can go for anonymous. I can go for anonymous. Why anonymous? Easy. If I want to create the two threads, create a thread class 1, implement runnable, create a thread class 2, implement runnable. Instead of doing like that, can I create two threads by using anonymous implementation? Yes. Let's take like this. Thread T1 is equal to new thread. Can I call this as one thread? Yes or no? Inside this thread, can I override run method? Yes or no? Yes. This is one thread. This is one thread. Similarly, can I create another thread? Thread T2 is equal to new thread anonymous implementation. Inside this also, we are going to override run method. Inside this also, we are going to override run method. Thread T1 is equal to new thread. I'm overriding run method. Thread T2 is equal to new thread. Here also, I am overriding run method. T1 run method, T2 run method. Perfect. Next one. Here, can I write like this? T1 dot start and T2 dot start. What is the meaning of that? Two threads are starting. So string S1 is equal to hi, string S2 is equal to hello. Here I am creating thread T1. Here I am creating thread T2. T1 dot start and T2 dot start. But what is my requirement? I should get the deadlock. I should get the deadlock. When I will get the deadlock? If resources are locked by the threads, resources are locked by the threads, then only I will get the deadlock. Now, here inside this run method, I'm going to write one synchronized block. Inside this, I'm going to write one synchronized block. First thread is holding S1. First thread is holding S1. Let me go to second thread. Let me go to second thread synchronized of S2. What is the meaning of that? First thread is holding which resource? S1. Second thread is holding which resource? S2. Is this diagram satisfied? Thread 1 is holding resource 1. Thread 2 is holding resource 2. How I am holding them? See, I have taken a deadlock class. My program should give the deadlock. My program should give the deadlock. Public static void main. S1 is one resource, string object. S1 is one object. S2 is one object. Here I created thread 1 with the anonymous implementation. Thread 1 is holding S1 by using synchronized block. Similarly, I created thread 2. Inside the thread 2, my thread 2 is holding S2 by using synchronized block. Are you guys clear? Are you guys clear with this? Yes. Now let's write system.out.println thread 1 locked. Thread 1 locked resource 1. Thread 1 locked resource 1. Okay. Then here what I am going to write? Thread 2 locked resource 2. Thread 2 locked resource 2. After locking this resource, let's keep my thread in the sleep state for 100 milliseconds. Let's keep my thread in the sleep state for 100 milliseconds. Surround with try catch. Surround with try catch. Now, here also, let me keep the thread in the sleep state for some time. Second thread also going to sleep state for some time. Are you able to understand this? Look at this code. Thread T1 is equal to new thread, public void run method. Inside the run method, I have synchronized block. T1 synchronized block holding S1. That means thread 1 locked resource 1. After locking, what happened, guys? There is an inverter, na? Not power, only projectors got stopped. Guys, online people, 1 minute. इसको भी ऑन करो भाई. ऑन ही है ना वो. खराब हो गया क्या? No, even if we lost the power, Immediately inverter will switch on. It should not crash. What, they don't know anything. आ गया. हाँ. नहीं 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 नहीं, नहीं, कुछ नहीं है. It will take some time, huh? Huh, right. So here I'm taking thread T1. It is having anonymous implementation. Inside this run method, I have written synchronized block. In that synchronized block, thread 1 is holding S1. Thread 1 locked resource 1. Similarly here, thread 2 holding S2. That is fine. Diagrammatically, thread 1 is holding resource 1. Thread 2 is holding resource 2. Thread 1 is waiting for resource 2. Thread 2 is waiting for resource 1. Let's do like this. Now, inside this synchronized block, within the block, I will write one more synchronized block to access resource 2. Thread 1 is thread 1 is waiting for resource. It is holding resource 1, waiting for resource 2. Synchronized of resource 2. Synchronized of resource 2. System.out.println thread 1 waiting for resource 2. Thread 1 is waiting for resource 2. Similarly, inside this synchronized block, if I write like this, it is waiting for resource 1. Thread 2 waiting for resource 1. Now look at this. S1 is equal to hi, S2 is equal to hello. Here I am creating one thread, that is using anonymous implementation. This is my thread logic. Inside this thread, I am overriding my run method. Inside the run method, I have one synchronized block. This first synchronized block is holding S1. That means it is holding resource 1. After holding the resource 1, what it is doing? Waiting for resource 2. Now, this is one thread, thread 1. When it comes to thread 2, what thread 2 is doing here? Holding resource 2 and it is waiting for resource 1. Then here, what I am doing? T1.start, T2.start. When T1 is started, what this T1 will do? T1 will hold S1, then it will go to sleep. Then immediately T2 is starting. What my T2 will do? T2 will start, T2 will hold S2. By the time T2 started S2, T1 will try to access S2, but S2 is already holding by T2. When the T2 is started, T2 will try to access S1. S1 is already held by T1. So T1 is holding S1, waiting for S2. T2 holding S2, waiting for S1. So two threads will wait for each other. That is called deadlock. Now let's run this program. Run as Java application. My program is terminated. My program is not terminated. Forever it will not terminate. Why? Two threads are waiting for each other. That is called a deadlock. So can I resolve this deadlock? Can I do anything? Can I do something to resolve that? No. So you need to write the code accordingly so that deadlock will not come. Once you get the deadlock in the program, we cannot do anything. No. Thread 2 locked resource 2. thread 1 locked resource 1. Now what is happening here? First I am calling t1.start, then I am calling t2.start. I'm starting two threads. I'm starting two threads. When I start two threads are executing parallelly. When T1 is started, T1 is holding S1, then it is going for some time sleep. Just T1 is started. When the T1 is started, it is calling run method. It is holding S1. After holding S1, it is trying to access S2 also. By the time JVM comes here, S2 already holded by T2. T1 is waiting for S2. T2 is waiting for S1. Both threads will not complete the execution. That situation is called as deadlock. Even I think 2 years back, when I attend the interview, they asked this question. Deadlock means theoretically everybody can tell. He asked me, can you write a program which will give the deadlock? So if you can write a program which will give the deadlock, that means you are very good in multi-threading. You are very good in multi-threading. How to create a thread, how to start a thread, what is synchronization, when to go for synchronization, when not to go for synchronization, when two threads will clash, when two threads will wait for each other. They asked this question to me. Can you write a program which will give the deadlock? If I run the program, first thread should wait for second thread should wait for the first thread. Both threads will be waiting forever. Both threads will wait for each other forever. See, my program is not terminated still. When it will terminate? Never. Never. Thread 1 is waiting for thread 2. Thread 2 is waiting for thread 1. Both threads will not release the resources. That is called deadlock. You should not buttify the program. You need to write the program step by step. How I started the program? First I created thread 1, thread 2. Then inside that I have taken one synchronized block. Thread 1 is holding resource 1. Then in the thread 2, I am writing synchronized block for resource 2. With that, thread 1 is holding resource 1. Thread 2 is holding resource 2. Then after I have written the logic, thread 1 is waiting for resource 2. Thread 2 is waiting for resource 1. Thread 1 will not release. Thread 2 will not release. Both threads will wait for each other forever. That is called deadlock. Understand? What is a deadlock? If two threads are waiting for each other, to release the resources, then it is called as deadlock. Good. Look at the diagram. With the diagram, you should understand how the code is implemented. By looking at the diagram, you need to understand how that code got implemented. We should not write this program in the real time. This program I am showing you for interview purpose. If you write deadlock in the program, project execute nahi hoga bhai. You can do it. Multiple instances is not possible. Na? Your class can extend from only one class. Anonymous implementations, you can do any number. In the previous example, how many anonymous implementations I have done? 3. This is one anonymous implementation. This is one anonymous implementation. This is one anonymous implementation. Na? Any number of anonymous implementations you can do. This class can extend from any other class also, no problem. Your class is free for inheritance. You can resolve that by using yield methods, by using join methods, you can resolve. That means you need to write the code not to get into deadlock. Once you get into deadlock, you cannot do anything. Now, can I do anything for this program? Kuch nahi kar sakte. Because thread 1 is waiting for thread 2, thread 2 is waiting for thread 1. Already we came into problem. We cannot do anything. Look at the program. S1, let's consider S1 as a first resource. Let's consider S2 as a second resource. Thread T1 is equal to new thread. Inside that I am overriding run method. In that I am writing one synchronized block. Here acquiring first resource, locking first resource and waiting for second resource. Here thread 2, it is locking second resource and it is waiting for first resource. First thread waiting for second resource. Second thread waiting for first resource. Both the threads will wait for each other forever. That is called deadlock. Where we will write this code in the real time? If you write this code, हमको घुमा के थप्पड़ मारता है आपका manager. You should not write this code in the program. Are you going to write this code in the project? Then why we are writing here? Interview. Interviewer may ask you to write a program which will give the deadlock. We should not write the deadlock programs in the project. Remember that point. Huh? Huh? 1 minute, 1 minute. We need to override all. Yes, here, no. Here I am overriding one method. Na? Is in the same block, here you need to override the another method also. No. You will write anonymous implementation for all the methods, but here you will call only one method, right? No, which method you call, only that method it will invoke, not all the methods. Yes, you can do it. You can do it. If you don't give the sleep, maybe first thread will hold both resources, right? If I don't give the sleep here, maybe first thread is super fast. First thread will occupy S1. If this logic also execute, it will occupy S2 also. Parallelly, they will execute. If I am keeping sleep, then it will wait for some time. By that time, second thread will take the resource too. Yes. No need. You can keep anything. No? Sleep time always milliseconds. I can keep 1000 also. If I don't write the sleep here, then first thread only will occupy both resources. Yes, that's why I'm keeping first thread sometime in the sleep mode. Sleep method holding two parameters, huh? Nanoseconds, milliseconds, comma nanoseconds. Milliseconds, comma nanoseconds. Yes. I'm directly giving milliseconds, 100 milliseconds. Okay, perfect. So with this we understood how to write a Java program which will give deadlock. This is just for interview, guys. Don't write this in the project. Java program which will give deadlock. Java program which will give deadlock. All right. Next one. There is another concept, guys. Let me go for demo class. Let me remove all these things. From now onwards, I no need to extend or implement. Directly we can go for anonymous. It is easy and less number of lines of code. Okay. Good. Yes. Now I want to create two threads, guys. I want to create two threads. Can you help me in creating two threads? What is the logic I need to write? Thread T1 is equal to new thread. This is the body. In this body, I need to override run method. In this body, I need to write the run method. In this run method, I want to print numbers from 1 to 5. I want to print the numbers from 1 to 5 by using a loop. For integer I is equal to 0, I less than or equal to 5, I plus plus. 1 to 5, okay, 1 I will give. Int I is equal to 1, I less than or equal to 5, I plus plus. Sys out, I want to print thread name and I value. How to get the name of the current thread? What is the method available? Thread dot current thread dot get name plus I. Thread dot current thread dot get name plus I. What it will do? What it will do, guys? T dot start. When I call T dot start, internally it will execute run method or not? Internally it is going to execute the run method. Run the program. Thread 0 is printing 1, 2, 3, 1, 2, 5. Some numbers are printing. Good. Yes. Thread 0 is printing 1, 2, 3, 4, 5. Can I give some name for the thread? Can I set the name for the thread? Yes. T1 dot set name. Can I set the name as thread 1? Instead of 0, I'm setting the name as thread 1. Thread 1. All right. Execute it. Thread 1 is printing numbers from 1 to 5. Any difficulty? No. I'm just creating a thread by using anonymous implementation. For that thread, I am setting some name and I am starting that thread. When I start that thread, internally it is calling run method. Run method is printing values from 1 to 5. After printing the value, I want to stop the thread for 100 milliseconds or 1 second. After printing the each number, my thread should take rest for 1 second. How can I give some rest to the thread? Sleep. What is the purpose of sleep? To stop the thread execution for given amount of time. To stop the thread for given amount of time. Once a given amount of time is completed, then what will happen? After the thread, after the given amount of time is completed, then thread will continue its execution. Thread will continue its execution. Perfect. Save this program. Try catch. Surround with try catch block. Perfect. Now run this program. Thread 1, 2, 3, 4, 5. Yes, my thread is printing a number. It is waiting for 1 second, then printing the number, waiting for 1 second, printing the number. So I created a thread. Thread T1 is equal to new thread, public void run method, loop. In the loop, I am printing a number along with the thread name. I'm printing the number along with the thread name. Then sleep mode, setting the name for the thread T1 dot start. Can I start the T1 once again? Can I start the same thread twice? Why? Thread can be started only once. Thread will have a life cycle. Thread will have a life cycle. New, runnable, running, blocked, terminated. Blocked and terminated. New means here my thread is created. Here it is called as thread creation with anonymous implementation. When I call the start, it will go to from new to runnable. When I call the start, thread scheduler will come. What is that thread scheduler? It will identify resources which are required to execute the thread. It will understand the priority of the thread. It will start the thread. When it start the thread, it will call run method. From runnable, it will go to running state. From runnable, it will go to running state. Once it comes to the running state, there is a break. Sleep method, 1 second. 1000 milliseconds equal to 1 second. My thread will sleep for 1 second. After 1 second is completed, again it will start execution. Again it will start execution. Once the loop is completed, my thread will be terminated. That is called dead state. My thread will die. That is the life cycle of a thread. Now run the program. Thread 1, 1, 2, 3, 4, 5. It is executing. Got it? Next one. Similarly, I want T2 thread to do the same action. I want one more thread to perform the same action. Can I copy paste? Yes. T2, it will do the same thing. T2 dot set name is equal to thread 2 T2 dot start. T2 dot start. T1 is start and T2 start. Run this. What is happening now? Parallelly, they are executing. Parallelly, they are executing. T1 started, T2 started. When T1 is executing, T2 is waiting to complete the T1, or both are executing at a time? Both are executing at a time. Are they maintaining the order? First thread 1 printed, then thread 2 printed. After then thread 2 printed first, then thread 1. After then 1 2, then 2 1, then 1 2. There is no guarantee on the order. Who will manage that? Thread scheduler. Now let's do one thing. Instead of starting this here, let's take it, keep it here. Both are same. T1 dot start and T2 dot start. Yes. Thread 1, thread 2, thread 2, thread 1, thread 2, thread 1, thread 1, thread 2, thread 2, thread 1. Two threads are executing parallelly. What is the advantage? More work we can do in the less time. More work we can do in the less time. If I want to send one message for 1 lakh users, do you send one by one? Can I execute here? Inside this method, I will write a logic. I will write a logic to send the message. I will create 100 threads. I will run. 100 threads will execute at a time. 100 messages will go at a time. So the execution process will become super fast when you go for multi-threading. If you don't use multi-threading, only one thread will be available. One thread should process all the messages one by one. It is a time-taking activity. To reduce that process, to improve the performance of the program, to complete more work in the less time, we are going for multi-threading. T1 dot start, T2 dot start, two threads are executing parallelly. We don't have any control on these threads execution. Now what I will do is T1 dot start, T2 dot start, in between I will call T1 dot join. What is the method I'm calling, guys? T1 dot join. There is a join method. Exception is there. Throws declaration exception. Join method is having one checked exception. I'm ignoring the checked exception by using throws exception. Before join, if I start two threads, how we are getting the output? How we are getting the output? I am getting the output parallelly. What is the meaning of parallelly? Two threads are executing at a time. Now I am going to call T1 dot join. I'm going to call T1 dot join. Run this program. What happened? Earlier, how we got the output? Now, how we are getting the output? Earlier, what happened? Earlier, two threads executed parallelly, but now only one thread completed the execution, then only second thread getting the chance. Whenever you call T1.join, thread scheduler will understand after completion of the first thread execution, then only second thread should get the chance. That is the meaning of join method. Once my thread execution is completed, then only second thread should start. T1.join. Suppose, for example, instead of this, if I call T2.join, what is happening now? thread 1 2, thread 2 1, thread 1 2, thread 1 2, thread 1 2. So whenever you start the first thread, if first thread is having a join method, then thread scheduler will make sure. Now see here, T1 dot start, T2 dot start, T1 dot join. What is happening? What is the conclusion? Before starting the another thread, if you call the join method, that thread will start once your thread completed the execution. Here, if I call the join method here, is there any use? No. Why? T2 already started. If I call T2 dot join, is there any use? No. T1 already started. Before starting the T2, if you call T1 dot join, then thread scheduler will hold T2 until T1 completed its execution. If you want to hold one thread execution until first thread completed the execution, then you need to go for join method. Let's run this program. Thread 1, only thread 1 is executing. Why? I kept T1 dot join. T2 started or T2 not started? Till T1 completed, T2 will not start. If you want to achieve this kind of requirement, then you need to go for join method. Join method is a static method or join method is an instance method. Join method is a instance method. On which thread I am calling the join method? First thread, T1 dot join. When I call T1 dot join, what is happening now? When I call T1 dot join, what is happening now? It will hold, thread scheduler will hold second thread to start the execution until first thread completed the execution. Until first thread completed the execution, second thread execution will be holded by thread scheduler. Are you getting my point? Yes. Now, similarly, now you see thread dot sleep, T1 dot start, T2 dot start is available. If I execute like this, now what is happening? Parallelly, they are executing. Now, here you can write one method called thread dot yield. What is the mean? Yield is a static method. Yield is a static method. Join is a instance method. Yield is a static method. Thread dot yield. Here also I am calling thread dot yield. Now see the difference. What is happening? 2 1 1 2 2 1 2 1 1 2. Basically, yield method is used to give the chance for other thread also to execute parallelly. Yield method is used to give the chance for other threads also to execute parallelly. I am one thread. I have here another thread. That thread, my thread, both are having equal priority. When two threads are equal priority, yield method will give the chance for other thread also to execute parallelly. What is the join method will do? Yield and join are opposite. Yield method and join methods are opposite. If I call join method, only my thread should complete first, then only second thread should come. When I call yield method, I will execute parallelly, you also execute. You are my brother, you also execute. I will execute, I will give the chance for you also to execute. So if you want to execute two threads parallelly, if you want to give equal importance for two threads, then you need to go for yield method. Suppose two threads are there, first thread should complete the execution, then only second thread should start. Then we can go for join method. To be frank, in 10 years of time, I have never written join method and yield method. Syllabus. Why we are discussing? Syllabus. Interview purpose. See here, thread dot sleep, here I'm giving only 100 seconds. Here I'm giving 15,000. Okay. Second thread is more time it is in the waiting, na? Sleeping, right? So first thread will complete it will give the chance. Your thread is going to sleep. We can't do anything. I'm just giving the chance for you to execute, but you are sleeping. I can't do anything. Right? Yeah. No. It will give the chance to execute. Execution logic, if you don't write sleep, then no problem. If you write the sleep, then there is a problem. Okay, so we understood what is the difference between join method and yield method. What is the difference between join method and yield method? Join method is used to hold second thread execution until first thread completed the execution. Join method. Join method. It is used to hold first thread execution until it is used to hold second thread execution until first thread completed its execution. Join method is used to hold second thread execution until first thread completed its execution, until first thread execution got completed. Join method is used to hold second thread execution until first thread execution got completed. A program T1 dot start, T1 dot join, T2 dot start. If you call join method after threads are started, is there any use? If I call the join method after T2, is there any use? No use. Do you want to call T2 dot join? No use, na? No use. Now, whatever experiment you want to do, you can try after the class. Right? Yes. Now, what is the purpose of yield method? Yes. Yield method. Yield method, it is used to give the chance for other threads to execute. Yield method is used to give the chance to equal priority threads to execute. Yield method is used to give chance for other equal priority thread to execute. Equal priority thread to execute. Yield method is used to give the chance for other equal priority threads to execute. Okay. How we will call yield method is a static method or it is instance method? It is a static method. Thread dot yield. Thread dot, instead of that, I think I have created one program. Yield demo. Yeah. Guys, see what we are doing. This is a regular approach. Class producer extends thread, writing run method, produced item. Okay. Class consumer extends thread. There is a consumer thread. I am extending from thread, but really this much logic is required. No, what we can do? We can do anonymous implementation, but still. Class producer extends thread. Inside this, we are writing run method. In that, I am writing a loop. In that, I am writing a loop. Produced item I. Then what I am doing? Yield. Then class consumer extends thread. I am writing run method. Consumer consumed item I. Then thread dot yield. So producer will produce, will give the chance for consumer. Consumer will consume, will give the chance for producer. Producer will produce, will give the chance to consumer. That means it is like a balanced execution. Producer will execute, give the chance to consumer. Consumer will execute, give the chance to producer. So consumer is one thread, producer is one thread. Now thread producer is equal to new producer. Superclass object is holding subclass object. Producer extending from thread. Can I say producer is a subclass of thread class? Superclass reference variable can hold subclass object. Thread producer is equal to new producer. Thread consumer is equal to new consumer. Producer dot start, consumer dot start. Run this program. Producer consumer, producer consumer, producer consumer. Parallelly they are executing or not? Why they are executing parallelly? Because of yield method. What is the purpose of yield method? First I will execute, I will give the chance to other thread. You also have a yield method. You execute, give the chance to me. One after other they are going to execute. If I go for join method, what will happen? It will execute the first thread. Second thread should wait until first thread completes the execution. Java program with yield method. Java program with yield method. Okay. And there is another concept in the multi-threading which is called inter-thread communication. How one thread can communicate with another thread. We have seen object class, wait method, notify method, notify all. Did we discuss those methods? No. What is object class? Come on. What is object class? Object class is a super class for all the classes in the Java. It is a default super class, either directly or indirectly. In that object class, there are several methods available. Can you tell me what are those methods? Come on. ToString equals hash code, get name, get class, clone, wait, notify, notify all. How many methods are there? Total 11 methods are available. Any class can access those 11 methods. Previously we accessed get class, get name, ToString, hash code, equals, clone. 6 methods we accessed, but we did not access 5 methods. Wait, notify, notify all. These 5 methods are used for inter-thread communication. If one thread want to communicate with the another thread, then we will go for inter-thread communication. So those 5 methods are related to thread. In the interview, they will ask a question. This wait method, notify all method related to thread class, thread functionality, right? Then why those methods are not in the thread class? Why in the object class? This is very common interview question. Are you getting my question? What is the question? What is the question? Why wait, notify all methods are available in the object class? Why not in the thread class? When we will use those methods? Inter-thread communication. Then why they kept in the object class? Why not in the thread class? Then every method should be there in the object. Why we have string class methods? No. Why multi-threading related, inter-thread communication related methods are available in the object class? Why not in the thread class? Why? They can keep in this here only, right? Now if you say concat method, why they did not kept in the object class? String is also extending from object, na? Why they kept in the string class separately? Buffer reader extending from object. Why readline method not available in the object class? Why it available in the buffer reader class? हाँ, subject सारा method object में होना चाहिए. Why they kept separate classes, but why only these 3 methods available in the object? Valid question or not? Huh? We need to ask Sun Microsystem. Oh, company hai nahi hai abhi. Sun Microsystem not available now. No. Inter-thread communication means our classes, our user-defined classes also can act as a threads, right? Our user-defined classes also now. What is this producer? Producer is a thread. And what is a consumer? Consumer is a thread. These are user-defined classes. User-defined classes are acting as threads. My user-defined classes should have inter-thread communication. Are you getting my point? Here, producer is one class. It is a user-defined class. This user-defined class acting as a thread. Class producer extends thread. Class consumer extends thread. So this class is one thread. This class is one thread. For these two classes, what is the default superclass? Now it is a thread. If I don't have a thread, then it is a object. So those methods are very common for all the user defined classes. Now, if I without extending thread class also, can I create a thread? By implementing runnable, by implementing callable. If I keep those methods, in the runnable or callable, what is the problem? Interfaces. Every class who is implementing runnable should override three methods. If anybody implement callable, they should override three methods. Unnecessarily it is becoming a burden, right? That is the reason they want those three methods to be available for every class in the Java. That's why they kept in the object class. What is the advantage if they kept in the object class? Every Java class can access those methods either directly or indirectly. Got it? If they kept in the thread class, then what will happen? Always you need to extend the properties from thread class. If you extend the properties from thread class, inheritance got closed. You cannot extend the properties from any other class. If they kept in the runnable, everybody should implement that. That is a problem. Unnecessarily, first of all, I'm going to implement runnable. I don't need inter-thread communication. Even though if I don't need inter-thread communication, I need to implement them. Are you getting my point? So that wait method, are you convinced? Are you convinced? Why they kept these methods in the object class? Why not in the thread class? If they kept in the thread class, it's if I want inter-thread communication, always I need to extend the thread class. If I extend thread class, what is the problem? In future, I cannot extend the properties from any other class. That's why they did not kept in the thread class. Instead of that, they might have kept in the runnable, right? Why they did not kept in the runnable? If I implement runnable, I need to implement run method and these four methods. I don't want inter-thread communication. Then also I need to implement. Why? In the Java, there is a rule. When you implement a interface, it's mandatory that you need to implement all the methods. When I don't need that, why should I implement? Unnecessarily, it will become a burden for the programmer. That's why, if I keep in the thread class, everybody should extend. They will not extend from another class in future. They will scold us when they want to go for inheritance. By already we are extending from thread class for inter-thread communication. I can't extend from any other class. If I keep in the runnable, unnecessarily why everybody should implement? Okay, thread class is not the right place. Runnable is not the right place. These methods should be available for everybody. If they want, they will call. If they don't want, they will not call. Let's keep in the object class. That is the reason behind that. Understood? Now tell me, why inter-thread communication methods are available in the object class? Why not in the thread class? If they kept in the thread class, we have to extend. Definitely we have to extend. If I extend, what is the problem? In future, I cannot extend from any other class. If they kept in the runnable, what is the problem? Unnecessarily, everybody should implement. Now they kept in the object class. What is the advantage? If you want, you call. If you don't want, you ignore it. That functionality is not mandatory for everybody. That functionality not mandatory for everybody. For some people, it requires. For some people, it does not require. That's why they kept in the object class. This is also interview question. For freshers, they will ask this question. Why these methods available in the object class? Why not in the thread class? People will tell, मुझे कैसे पता चलता? Sun Microsystem को पूछना पड़ेगा. James Gosling. Lot of analysis we need to do. All right. Inter-thread communication. Inter-thread communication. Inter-thread communication is used to establish communication among the threads. It is used to establish communication among the threads. To achieve intercommunication, we have below 3 methods in the object class. To achieve inter-thread communication, we have below 3 methods in object class. First one is wait method. Second one is notify method. Third one is notify all. Wait, notify, notify all. Why these 3 methods in the object class? Why not in the thread class? Why these 3 methods available in object class? Why not in thread class? Okay, what is the reason? If it is in thread class, if these methods available in thread class, then we have to extend thread class. We have to extend thread class. In future, we cannot extend from any other Java class because Java is against for multiple inheritance. Java is against for multiple inheritance. If these methods available in runnable interface, then everybody should implement these methods even if they don't need inter-thread communication. Even if they don't need inter-thread communication, those people need to implement these methods. To overcome all these problems, Java kept these methods in object class so that every class will have access. Every class will have access for these methods. If we want, we can call. If we don't want, we can ignore. That's it. Now, sir, when we need to go for inter-thread communication, okay. In the old movies, have you seen police people will have what is that? Walkie-talkie. Hello, I'm at Amirpet, completed. Then what that person will tell? Okay. Walkie-talkie. Hello, I'm at Panjagutta, completed. Over. I'm at Amirpet, over. I'm at Panjagutta, over. That means first person will say, I'm at Amirpet, over. What is the meaning of that over? I am informing that my talking is completed. Whatever message I want to tell them, that I will tell a message. Hi, I'm at Amirpet, traffic is under control, over. That means I'm telling them. What next they will tell? I'm at Panjagutta, very good traffic is available here, over. That means one person doing some action, notifying to another person. That means he is sending a notification to another person. Then what that second person will do? When he receives the notification, then he will tell his task. he will complete his task. Then he will notify to first person, I am done. Then second person will do the task, will say, I am done. That is wait, notify. First thread will be executing some logic. First thread will be executing some logic. As part of this logic, it is waiting for other thread to complete the logic. When other thread completed the logic, other thread should send the notification to the first thread. After receiving the notification, first thread then continue the execution. First thread is started. First thread is waiting for second thread to complete. How first thread will understand second thread is completed? Notify. First thread will be in the waiting state. Then second thread is continuing the execution. When the second thread completed the execution, second thread will give the notification to first thread. Then first thread will continue the execution. Simple example. Month started. You need to pay the hostel fees. Yes or no? So you have been to ATM. You try to withdraw the money. You kept ATM card. You enter 5,000. Catch. No balance. Then what you will do immediately? You will call to your father. Papa, अभी तक पैसा नहीं आया. मैं वापस आऊं क्या घर को? Yes or no? You will tell to your parent. आज second date. अभी तक पैसा नहीं आया. I am coming to home tomorrow early morning. सिकंदराबाद से मुझे ट्रेन है. बेटा रुको मैं अभी पैसा देता हूं. आप मत आओ. Yes or no? Yes or no? Parents will tell like that. You don't come. You wait. You wait there only. I will send the money. Then father will go to the bank. He will deposit the money into your account. Then he will tell you, okay beta, paisa deposit kar diya. Then what you will do? That means first you are telling to your father, money is not available. Then your father is depositing the money in the bank account. Then he is notifying you, yes, I have sent money. Then what you will do? You will withdraw the money. Can I say it is a communication between you and your father? Yes. You need to consider yourself as one thread. Your father is also one thread. You started executing that ATM logic. You are trying to withdraw the money from the ATM, but money not available. Then you need to wait till money added to your account. So your father will go to bank. He will add the money. He will notify you. Beta money sent. Then you will execute that logic. You will withdraw the money. That is called inter-thread communication. Two threads are executing. First thread is waiting for second thread to complete the task and notify the first thread. After receiving the notification, first thread will complete the execution. That is called inter-thread communication. How to achieve that inter-thread communication? How to achieve inter-thread communication? By using three methods. What are those? Wait method, notify method, notify all. Inter-thread communication is used to establish communication among the threads. To achieve inter-thread communication, we have below three methods in object class. What are those methods? Wait method, notify method, notify all method. Why these three methods available in object class? Why not in thread class? We understood the reason already. All right. Okay, I prepared one program, guys. Inter-thread communication. Not this one. Customer. Okay. Here there are two methods available. One is deposit method and the second one is withdraw method. This method is synchronized method. What is the meaning of synchronized method? Only one thread can access at a time. Now, inside this withdraw method, I have a logic to withdraw the amount. Going to withdraw. I'm taking one amount to withdraw. It is checking existing amount is less than the given amount. Then this dot amount is less than given amount. Your account is having 10,000, but you are trying to withdraw 20,000. Then what it will do? Less balance, waiting for deposit. How I will do that? Wait for deposit. I'm calling wait method. It will be in the waiting state. It will be in the waiting state. So once the waiting state is completed, when this wait will complete, if the second thread notify, then only this wait will complete. After waiting is completed, this dot amount is equal to this dot amount minus amount. Then I will say withdraw complete. Then what is this deposit method is doing? Going to deposit. This dot amount plus is equal to amount. System dot outer printer deposit complete. Then after completing the deposit, what I'm doing? Notify. When I do this notify, what will happen? Withdraw will be complete. First thread withdraw method will be waiting for second thread to complete. Second thread is doing the deposit and doing the notify. One thread will be waiting for other thread notification. Now customer class is created. New thread dot start. What is the meaning of new thread dot start? Can I say this is anonymous implementation? This is very short form. New thread. Earlier what I have done, thread T1 is equal to new thread. Then I have done T1 dot start. But here directly start. Here this is anonymous implementation. This anonymous implementation I'm storing into a variable called T1. Here I'm not even storing into variable. I'm not even storing into variable. Directly new thread anonymous dot start. Okay. I removed this part. Directly I'm calling start. Then storing into variable also not required. Got it? Yes. Now this object is also not required. Oh, sorry. I'm calling the method. So first thread started. In the first thread run method I'm calling withdraw. In the second thread I'm calling run method deposit. What is the existing balance? 10,000. How much I'm trying to withdraw? 15,000. Condition will satisfy or will not satisfy? Will satisfy. Balance is 10,000. I'm trying to withdraw 15,000. Existing balance is less than given amount. Then what my thread will do? Wait until which time? Second thread is going to deposit. When second thread deposit, what it is doing? Is it just doing the deposit or is it calling notify? It is calling notify. When it call the notify, what will happen? Waiting thread will continue the execution. Run this program. Going to withdraw. Less balance. Waiting for deposit. Going to deposit. Deposit got completed. Then withdraw got completed. Understand? Yes. Now look at this. This is withdraw method and this is deposit method. Now do you want to wait for some time? After a deposit completed, notify. Where I need to keep the sleep, man? Waiting for this. Yeah, let me keep some sleep time. Thread dot sleep. What happened? Okay. Now let's wait. See here, going to withdraw, less balance, waiting for deposit. When the deposit is completed, then it will continue the execution. First thread will complete the execution. So can I say two threads are communicating? Can I say two threads are communicating? How they are communicating? By using inter-thread communication. See here, when I run this program, first thread started going for withdraw, but balance is not there. It is waiting. When it will continue, once the balance comes, how it will know that balance added? Notify. Second thread will deposit the amount, then it will notify. When it's notified, waiting thread will continue the execution. See, it is still waiting. Yeah, going to deposit, deposit completed. Then once the deposit is completed, then first thread withdraw the amount, withdraw completed. So can I say this is inter-thread communication? Yes. So what is the purpose of inter-thread communication? What is the purpose of inter-thread communication? To establish the communication between two threads. Java program with inter-thread communication. Java program to establish inter-thread communication. When you call notify, it will notify the thread which is in the waiting state. All right. So here this is a customer class. Int amount is equal to 10,000. Withdraw method going to withdraw. If the amount is not sufficient, it is going for wait. At the same time, second thread is also going to start. Second thread is doing the deposit. After doing the deposit, the second thread is doing the notify. Once it is notified, then it is going to call the first thread. First thread will execute. By using wait notify, we are able to establish inter-thread communication. All right. So in multi-threading, what we understood so far? What is multitasking? What is multitasking? What is multi-threading? What is multi-threading? Then next one. Advantages of multi-threading. Advantages of multi-threading. Default thread in JVM. What is the default thread in JVM? Default thread in JVM, that is main thread. Getting the information of the default thread. How to get the information of default thread? Thread.current thread. So getting info of main thread by using thread.current thread. By using thread.current thread. Creating user defined threads. Creating user defined threads. How many ways are there? 3 ways. One is by extending thread class. Second one, by implementing runnable interface. By implementing runnable interface. Then by implementing callable interface. By implementing callable interface. And we discussed about run method versus call method. What is the difference between run method and call method? Run method return type is void. Call method return type is object. Run method versus call method. Executor service. What is executor service? Pool of threads. Executor service. It is used to work with callable pool of threads we are going to create. We discussed about run method versus start method. We discussed about run method versus start method. What is the difference between run method and start method? Run method will contain the logic to execute by the thread. Start method is used to start the thread. Then we discussed about thread life cycle, and we discussed about thread scheduler. We discussed about the thread scheduler. Then synchronization method and block. What is thread safety? We understood what is thread safety. What is thread safety? Only one thread can access the logic at a time. Always is it recommended to go for thread safety? No. Depends upon the project requirement, we will go for thread safety. Thread safety we understood. Then we discussed about thread creation with the anonymous implementation. Thread creation with anonymous implementation. Thread creation with anonymous implementation. And we discussed about deadlock. Deadlock. Java program to give deadlock. Java program to give deadlock. All right. Next we discussed about join method and yield method. Join method versus yield method. What is the difference between join method and yield method? Join method will hold second thread to start until first thread complete the execution. What is the yield method? Yield method will give the equal priority to the second thread to execute parallelly. And we discussed about inter-thread communication. What is the difference between inter-thread communication? What is the difference between, sorry, what is the purpose of inter-thread communication? Come on, guys. To establish the communication between the threads, we will go for inter-thread communication. How to establish communication between two threads? Wait and notify. Why those methods available in the object class? Why those methods available in the object class? Those methods are required for every class. That's why they kept in the object class. Okay. So with this, we completed our discussion related to multi-threading. Daemon thread. We discussed about one more concept called daemon thread. What is the meaning of daemon thread? The threads which runs in the background, low priority threads are called as daemon threads. JVM will not care about the daemon thread. Even if the daemon thread is running, if main method reach end, then JVM will stop the program. Daemon threads are nothing but background threads. Perfect. If you want to notify all the waiting threads, then we will call notify all. Time, how much time you need to wait? So you need to give the time period. If you don't give the wait, it will wait until it receives the notification. I want to wait for only particular amount of time. Then you can give the parameter for the wait method, milliseconds. No, it will wait for particular amount of time. It will continue the execution. All right. Tomorrow we will start the class at 5 o'clock. Tomorrow class is 3 hours and I will give some break in the middle, 15 minutes chai peene ke liye. Because yesterday I have taken leave na, I will compensate that tomorrow. Offline only. Tomorrow class will start at 5 o'clock, offline and online both. And Sunday also class will be there. Tomorrow I will confirm the timings for the Sunday. I want to complete all the pending topics by this weekend so that from Monday with fresh mind we can start collections. All right guys, thank you. See you tomorrow at 5 o'clock.